All right, boys and girls, we're going to go through this video, going through each of these questions together today since a majority of you were on campus taking the FSA, and I know that we probably got out of that meeting, and by the time parents got there to pick you up, and then you guys probably went to lunch, I don't want you to rush to have to come back to meet at 2 o'clock, so let's go through these problems together. Maybe it's, before 2, that's okay, or if it's after, but no worries. If you didn't get to do it, then just pay close attention to this video and kind of work through these problems as I'm solving, and we'll be fine. Question number 1, this is a good review, going back and looking at angles within a circle. So the question reads, how many degrees is the angle that turns through 1/6 of a circle? So for these questions, I like to draw a picture, and then I like to imagine cutting this into 6 equal parts. Right? We know that if we cut it into fourths, a circle, then each of these parts would be equal to 90 degrees. So we know that 6 equal parts is going to be a little less than 90 degrees, but let's draw another circle here. And I'm going to first cut it in half, and then each of those parts I'm going to cut into thirds. So I have 3, 4, 5, and 6. Now they're not equal, but I did my best. And I want to know the angle measure of just one of those parts. Well, there's a couple ways that we could do this. We know that when we cut this circle right down the middle there, that's equal to 180 degrees. So half of my circle is equal to 180. Well, that's made up of 3 parts right there. So I could take 180 and divide it by 3 to figure out how much each of these pieces is worth, I guess. In my brain, that's how I think of it. Or how many degrees are in each of these pieces. And I know that 3 can go into 180 evenly 60 times, because I know that 3 times 6 is 18, and then adding on that 0 would equal 180. So a total of 60 degrees for each of these. Now there's another way that maybe some of you did this. Maybe you thought, okay, well, if I divided it and I have 6 equal parts, so now looking at the entire circle, and you would think to yourself, well, 6 times what number would give me 360? Because we know that a circle has a total of 360 degrees. So we know that 6 can go into 36 6 times. And then if we need that 0, we would just have to add on a 0 here. Still arriving at the same answer of 60 degrees. Let's look at question number 2. Select all the true statements about angles. So this is a select all, and we're focused on angles. A right angle makes a square corner. I know that's true. A right angle is wider or open more than an acute angle. So is a right angle larger or open more than acute? Yes, that's true. A straight line is an obtuse angle. A straight line just goes on and on forever. An angle must have a vertex or an endpoint where they meet. So this is incorrect. A line is not an obtuse angle. A straight line is a straight line. All acute angles have the same measure. Well, I know that's not true. I might have an angle that's open just like that, or I might have an angle that's open just a little less than 90 degrees. So these two do not have the same angle measure. That's false. An acute angle is less open than an obtuse angle. Acute versus obtuse. Well, this would be like an obtuse angle here, and that's acute. So is this open less than this? Yes. E is also true. Let's look at number 3. Which angle below is an obtuse angle? So what I would do, I would just look for each one and I would darken it. For this video, I'm going to highlight it. So ABC, that'd be ABC. That's not an obtuse angle, that's acute. Now let's look at ABD. Now I'm looking at this angle, ABD. That's a right angle, so that's not true. ABF. Well, that would be ABF. That's a straight angle. Let's look at CBF. CBF. So that's this angle right here, and that is obtuse, so the correct answer is D. Select all the possible names for the shape below. Well, right away I'm thinking, I know it's a quadrilateral because it has 4 sides. So C is correct. Now, is this a square? Squares have all 4 right angles, and this is not a right angle, so right away I know that this is not a square. A trapezoid. Well, in order to be a trapezoid, I have to have just one pair of parallel sides. Only one pair of parallel sides. So does this figure have one pair of parallel sides? Yeah, the top and the bottom. They can continue going forever and ever, and they will never meet or cross. So this is a trapezoid. Is it a parallelogram? Parallelograms have 2 pairs of parallel sides. So this figure does not have 2 pairs, because if we continue these 2 lines on and on and on, eventually they would meet or cross. So these are not parallel. It is not a parallelogram. Rectangle. Rectangles have 4 right angles. This figure only has 2. It is not a rectangle. So just B and C. Let's look at number 5. Which figure always has at least one pair of perpendicular sides? So in this example, my brain automatically wants to draw each figure. So an equilateral triangle. All 3 sides are the same. Are there any perpendicular sides? No. A square. I know a square has 4 right angles. All 4 sides are the same length. And there's 2 pairs of opposite parallel sides. So this will always have one pair of perpendicular sides, meaning they meet and cross to form a perfect right angle. Now let's look at a parallelogram. Parallelograms look like a rectangle that's been squashed. Well, do you see any perpendicular sides? No. If you highlight these lines right here are not perpendicular. They do not form a square corner. Neither do these 2 sides. So a parallelogram is out. Now let's look at this one, a quadrilateral. Well, isn't that an example of a quadrilateral? Yeah. Isn't a rhombus an example of a quadrilateral? These don't have any perpendicular sides, so quadrilateral will not always have at least one pair of perpendicular sides. The only one that will is going to be B, a square. All right, let's continue on the back. Choose the name that best describes a figure with one angle greater than 90 degrees, 2 angles less than 90 degrees, and 3 sides. All right, so 3 sides, I know quadrilaterals out. It's got to be a triangle. But now let's look. One angle is going to be greater than 90 degrees. So I'm just drawing that. And then 2 angles less than 90 degrees. So there's my bigger, I guess I could make it a little bit bigger. There we go. So let's make it a little bit easier to tell it's not a right angle. So there is my obtuse angle right there. And then here are my 2 acute. So what type of triangle have I formed? This is an obtuse triangle because it has one angle that's greater than 90 degrees. Number 7, moving right along. Victoria cut a paper rectangle along the dotted line segment. What type of figures did she make? Well, if this is a right angle and this is a right angle, she formed 2 right triangles. Is angle ABC right, acute, or obtuse? That's angle ABC. That's an easy one. It's right. It has this square corner. Number 9. Select all the figures that have at least one obtuse angle. This is a right angle. These are both acute. A is out. B, right down here, right, 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 right. B is out. Let's look. Now we are on C, obtuse. This is obtuse right here. C has at least one obtuse angle. D, this is obtuse, so is this one. These are both acute. D has at least one obtuse angle. E, acute, acute, acute. The correct answers are C and D. Last one. This picture represents a, it travels on and on and on forever in both directions. It is B, a line. All right, guys, great job. Let me know if you have any questions about these problems.